Good morning. Start chalking, Menominee.
Hello? Hello?
Mike, do it. Keep going. You can do it. You can do it. Nope, you got to try harder. Sorry. The
Hello?
silence of Chippewa wins out. Oh, there you go. Go right up to the microphone and talk. That
Hello?
should do it.
Hello?
Talk. I do not understand that at all.
Hello?
Go. Unbelievable. Just have a continuous conversation. See if that helps.
How was your day?
I think I hear somebody out in the hall in Chippewa. That might be why you're losing out to them. I wish there'd be a way that I could cut somebody out. Let's see here. Equal. Let's see here. Oh well, we'll just live with them. All right, when we left off, we were on page 330. This is something you have to be able to do, and in fact, we're going to be doing with a different set of problems in a couple seconds. So let's go through from table to formula. To exponential formula. Step 1, confirm that all new divided by old are equal. If you recall, when we were doing this problem, our new divided by old was 0.28. In other words, each successive one down the table was 28% of the previous one. So if you look back at the table, let's confirm that by taking out our calculators and doing 0.622 divided by 2.22. And it is, you got to do it with your calculator. It only works if you use your calculator. 0.174 divided by 0.622. And then 0.048 divided by 0.174. So, if you notice, each one of them is 28% of the previous one. If that is true, you should be able to take this 0.758 and multiply it by 0.048 to get the next one down in the table. So let's fill in the next one in the table. So in each case, we were taking this number divided by the number above it, this number divided by the number above it, this number divided by the number above it. Now we're going to take this number times our 0.28. So times 0.048. And what did you get? I know it's Monday, you guys, but we got to get started right away because we got a lot of stuff to do. So we can't, wait until our brains wake up. You got to start the game at the beginning, not halfway through the first quarter. What'd you get? Okay, so this spot here is 0.013. What is this one here? If you notice, each one is 1.25 bigger than the previous one. So what's this number over here? Add 1.25. 5.30. So in other words, the next one over on the table will be over 5.3 and up 0.013. Okay, so step one is confirm that all the ratios are the same. From table to exponential formula without a. If you remember, we had a problem with this graph because it didn't tell us where the zero value was. Remember that? We didn't go all the way back to the origin, or if you wanted to look at it on the graph. We didn't continue back up here. Does anybody remember what we got for that value? It's as many wise men as there were. You don't know. Have you ever heard the carol, We Three Kings of Orient? You never heard that one either, huh? How many Beatles there are without counting the drummer? So many people are sitting at this table over here. I don't know. It's got to be something. 3. Okay. And the number, we figured it out right there. But, so step 1 is to get that ratio the same. Step 2, the denominator of the exponential is the change in time. Which, if you notice, we said the denominator, t over, was 1.25. Well, how did you get those answers? You just took each one of these x's and figured out how far it is between the x's. Step 3, substitute a point. Well, the point we used was 2.2. And we said 2.2 is a times 0.28. Where did the 0.28 come from? It's the ratio of new divided by old. To the, where did the 0.3 come from? That's our first time. This was our first amount that the spring moved. This was the time that it was up to that peak. It's the coordinates of this point right here. So we just substituted that in, and we took on our calculator 2.22 divided by 0.28 to the 0.3 divided by 1.25, and we got 3.01. Page 331. Now, on this picture of the scale, I don't know if they took the weight of the bananas while it was still oscillating. You know how when you put something on a scale it like vibrates back and forth? I don't know if they didn't take the right picture or if they took it while it was too high. But when the scale eventually settled down, how do I know it was pointing to the 2 if you look at the graph? So you see the graphics goes brr, 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 and eventually it settles down at what value? 2. So when you go through this, in order to have the math work out, I would like you to add another column to the table. Remember, we're not talking in this example. We aren't talking about what it happens compared to 0. We're talking about what it happens compared to 2. So how far away is this last value from 2? Okay, so what are you going to do to each one of these values above it? What are you going to do? Subtract 2 from each one of them. These are the numbers you're going to use for your new divided by old. Go! I'll walk around and help you. Find the formula. W as a function of t equals a b to the t over k. Get to work. I'll help you. Did you guys write down the steps to do? Okay, good. So what's the first thing you're going to do? And so what did you get for so point? Show Felicia. Because she did, oh, now she's doing it. You know what you're doing? Great. Next page. Nope, yep, here. You know what you're doing? Yep, you're on the right track. Marlena, can you help the rest of your team?
Yeah.
Okay. So did the math work out? You didn't do your ratios yet. Okay. Connor, you know what you're doing with your ratios?
Not really.
Oh, you're just getting the subtractions first?
Yeah.
Okay. Here's these numbers have to be the exact same. Right? Are they the exact same? Try subtracting 2 from each one of them. Write that number over here for 2 from each one of them. So this one would be 1.46. Just write it down.
Subtract 2 from.
Yeah, so write 1.46, 0.779, 0.415, got it?
So we're trying to find
Point. Now do this divided by that and see what you get. Nope, the other way. You have to do the new divided by the old. You were doing old divided by new.
I don't know if we should take that one or if we should take the other. I don't know, the other notes is something about finding A is equal something. And then I know that the 2K is the thing.
So, I don't know.
It's like, I don't know, the other one, you can use the other point.
Oh, did you get it?
That, and
I'm getting there.
Okay.
take the differences that you just found.
Do you have a calculator there? And or would you like one?
My calculator just died last night.
Would you like to borrow one of mine?
That would be awesome.
Okay.
No, honestly, I would.
Usually you aren't one that needs to self-advocate, but apparently sometimes you're self-advocating. Of course, it is Monday morning. It might not be a lack of self-advocating. It might be weekend jet lag. Did you guys get it? Did you guys get the ratio? Okay, so, well, our B is 2.
Where's one?
So 2 plus. But you don't have to worry about that till the end. Let's just do the formula without 2, because that'll be just at the end. So you have 0.53 to the,
And the ratio
on my
is
sheet, what do I have? To the T over
K, yes.
K.
Oh.
Not the ratio.
So all we need to do is figure out what's K.
No, we're trying to figure out what's K. Ratio of K. So it's
Ratio.
K is the T, the difference in T's, right?
K
Which
is
is
like
how much? They're all point.
I think A
Good
might be
notes.
I might have to do it on my calculator. That's too much math for my head right now.
Old are equal, but it says.
Does it make sense, Felicia, that the second time? Okay. Did you do this?
Oh no.
So what's B then? We are trying to solve for.
You're trying to solve for too many things at once. Just figure out the ratio.
Well, I just want to know what the equation means so I know what to do. So.
Okay, it's in your notes, but I'll do it again.
I have the notes down, but I don't know what they mean.
That's what I said. It wasn't in your notes today. It was in your notes the other day. Go back to. It was a while ago.
Just divide by that, and that divide by that.
Here it is.
Okay, so that'd be 2.
You're absolutely right.
So your formula is A is the initial value, or the place where it crosses the x-axis.
Yeah, I have that.
Okay, I know. That's why I'm showing you. You've had this before.
Okay.
Okay, but we don't know that. We have to find that. That's one of the variables we have to find.
And that's A, right?
No, that's in your formula. It's A.
Formula, it's A, okay.
And then the base is what you just found, the new divided by the old.
Okay. So that's not K then?
Just wait. The variable is t,
Okay.
right? But that t makes it sound like all t's are equal. Our t has to be divided by how far it is between our t's.
Yeah, which is the new and old one.
Which is the first the change in the first column.
Okay.
This is the initial value. B is the change in new y divided by the old y. Or the ratio. Remember? K is the new x minus the old x, or it's the change in x. In the one that we did together, it was 1.25. Does anybody have a good handle on, I'm pretty sure I know what K is in this case? What'd you get, Marlena?
0.53.
That's A, or that's B. That's the new ratio divided by the old ratio. What's the K? Nick?
0.8.
I thought it was 0.9. The change in the new x minus the old x. How far apart are your x's? Look at your x's. How far apart are they? Or your times, I should say. The first columns.
Yeah, that's 0.9.
0.9, right? So give me the formula that you have so far. Weight as a function of time is A times, what'd you get for your ratio? Was it 0.53? I forgot if it was, is that this one? 0.53 to the t over 0.9. Now you got to be honest. Tell me which one of those things you don't understand how we got it, because you got to be able to do this for the test. So this part here, t, is a value we know from our table. This part here is a value we know from our table, because our table columns are t and weight as a function of t, right? We could use, I gotta find them again, 0.45 as t. We could use 1.35 for t. We could use 2.25 for t. We could use 3.15 for t, 4.05, 4.95, or 5.35. We could use any one of those. Oops, I shouldn't have made them in black. Should have made them in green. Sorry about that. And then our W's of t, we could use 1.46 or 0.779, 0.415, 0.221. 0.118, 0.063, or 0.033. I always use the first one in the table. Why? I don't know. To me, I use the first one because if I'm going to get back to here, I want to be as close as possible to there when I start. Okay, so how far back am I going to go? Okay, so that's what I'm going to substitute in. So I've got 1.46. That comes from here. Equals the thing I'm looking for. A times 0.53. We know where that came from. To the 0.45, that's our time, over 0.9. How do we get the A all alone? Divide both sides by 0.53 to the 0.45 over 0.9. So on our calculator, where is it? There it is. So on our calculator, we would press. I gotta get my glasses. I think. Maybe I don't have to get my glasses. Oops. 1.46 divided by 0.53 to the 0.45 divided by 0.9, which is, did you get 2.005? So A is what value? Two. So our formula is weight as a function of time is how far offset, what did we have to do to get this column here? Start at 2, right? Is 2 plus, what was our A value? 2 times, what was our ratio? 0.53 to the T divided by 0.9. Maddie.
So how do we know how much to subtract from like the table originally? Because you just said 2. So how will we know?
Good question. If they give you the graph like this, it's kind of easy.
You just know it's 2. Or
What value is the exponential getting closer and closer to?
2.
2. How far away is that from the origin? 2. So that's where the B value in your formula comes from. The formula that's in the book on the previous page, or no, the top of the page there. Their B that they call up here. That's where this 2 came from.
Okay.
Okay? Now, if that's not there, which we're going to be, or else we did do one, I can't remember. Yeah, we did this one back here. If you have a situation like this, and if you recall, we didn't know, or no, they did give us the initial population was 501 penguins. But they didn't give us what the end value of our logistic function was, which was 9,000, 10,000, I don't remember how many penguins could live on the island. Okay? If they don't give that to you, you've got 2 variables. Now, what's neat about that is that Desmos would be able to figure it out.
Yeah.
Okay, but if you don't have that, put it this way, for this class, they will never ask you that question. They will always have the graph go far enough so that you can see it's going to get towards this value here.
Okay.
They'll always give you that part. This one, either I didn't read it correctly, or if you remember question 2, I struggled with that because it says find K. Well, there were 2 variables. If there are 2 variables, you can't figure out the answer because you've only got one equation. You can figure out a bunch of different values, but you can't figure out the value. Now, that being said, here's how Desmos figured that one out. If you would have done it in Desmos, is that it plugged into that formula. This is the T, and this is the penguin population a whole bunch of times. And then it just backtracked by calculating backwards to figure out a value of K that worked for every single one of them, and a value of R that worked for each one of them. So it actually used calculus to figure it out. The way they told us to do it is use the number for R that was in our preview assignment. I think it was 0.13%, 13% increase per year. I don't remember what the percent increase on the rabbit or the penguin population was. It is something like that. Page. $333. AEDs, what is it? What do the letters stand for? Nobody knows.
Automatic external defibrillator.
Yeah. So, has anybody ever seen one in, well, we've got them all over at school here. Okay. Good internet search thing for people who are going into the medical field, say becoming a doctor or a veterinarian or something, would be to do a search on how useful are these things in saving people. Okay, why is that so important? Well, at church they wanted to buy one, and I said, you guys don't buy one. Because if people at church need to have an AED, they're probably going to die eventually anyway, like within a little while. Why? Because the people who need one at church, their heart probably broke out because old people go to church. Okay. At school, we have a lot less chance of needing an AED, but a lot greater chance of the person being able to live after they need an AED. Why is that?
Because they're most likely younger.
Very good. Actually, the only people at school that it probably wouldn't work for would be the teachers. So the return to good health that you have after an AED is related to how old you are. Okay? And, I mean, check it out on the internet. Look it up. You'll be amazed at how bad the results of AEDs are. Okay, so we have this AED. How does it work? It does what to your heart? Does it do it, like, quickly or slowly?
I feel like it goes at a pace, doesn't it?
It doesn't do it twice. It only does it what?
One big shot.
One big shock. Well, you have to understand how a capacitor works. A capacitor is a thing that stores electrical charge. Okay? So inside that AED is a little battery, but is a big capacitor. Okay? The job of the battery is to keep the capacitor fully charged. So it's kind of like a pump that fills a water tower. Okay? Or it's like why you have a tank on the back of your toilet rather than just having the water squirting into the toilet. It doesn't like give you enough volume to take care of the issues at hand. Okay? So that battery, I could hook the battery up to your heart and it'd be like, yeah, I can't even feel that, Kevin. Okay? Have you ever like lit a 9-volt battery?
No.
It's a cool thing. Take you know those 9 volts, those square batteries? Take one and lick it and see. You'll get a little shock. It's not going to be enough to start your heart. What's that?
So will I get better at math
Will I get better at math? Probably not. Okay, so they talk about an AED here. Then when somebody eventually donated one to the church, so then they said, well, we need to have practice on how to use it. And I said, no, you don't.
Just take the 2 sticky pads and put it on there.
Because the directions are right there on the box, okay? It's gonna work, okay? You don't need no stinking directions. Okay, like other types of defibrillators, an AED contains a capacitor that stores electrical energy and then discharges it quickly. How quickly do you think it takes a capacitor to discharge its energy? A second. What?
Not even a second.
Not even a second. Well, let's find out. Bottom of the page. Here's the formula that they have for our capacitor, voltage as a function of time is 1200 e to the negative 33.3 t. Let's go through it and see if we can figure out what we know this means. This part here, what's that first number always means? Good. So when they say the AED has 1200 volts, what are they saying? That's how much voltage it stores in energy. Okay. Oh, we have to talk about what voltage means. Voltage is like a waterfall. This waterfall is 1200 volts. Okay? Now, if you take a balloon and rub it on your hair, it gets to be way more than 1200 volts. So it gets much, much bigger than 1200 volts. But why can't I, like, if your heart quits working, why can't I, like, shock you with a balloon and get your heart to start working? Well, because the 1200 volts is how far the water falls. It's not how much water is coming over the falls. Okay, so if you would go to, do we have a falls around here?
Big Falls.
What? Big Falls. If you would go to Big Falls, that would be about enough energy to shock your heart. If you tried to do Niagara Falls, okay, charged to 1.5 gigavolts, okay, what would happen to the person's heart? Would it start?
It would explode.
It would explode probably. Way too much, not voltage, because that's how far it falls. Way too much current flowing through the heart. Current is amps. Okay, so that's what's wrong with the balloon? It's a much bigger falls. It just is like a trickle, like turning the faucet a little bit, right? It's not going to be enough to start your heart. Okay, so 1200 volts. That's how far it falls. Okay. In an exponential function, which this one is, when the base is e, this part here tells us it's decay. This part here is the percent of that time. So in this case, it says well, they don't really say it, but on the table on the next page, they say V is in volts, and they say T is in seconds. Because I don't see it any other place that it tells us what V is and what T is. Do you? It doesn't say, except for in the table. Okay, so it's discharging, it's getting less. So that after 1 second, it has gone down, not 33.3%, because it's really a percent written as a decimal. So it's going down 3,330% per second. Okay? So if we take, I gotta get my calculator out. If we take 1,200 divided by 3,000, let's see. Well, let's do 33.3. I think that, no, that won't be enough. It's, yeah, 1,200 divided by 3,330, we would get 0.36. So if we were going to graph this, which you're going to do, and you were going to graph it all the way over to 1 second, at 1 second, it would be 0.36 if it started here at 1200. So going all the way over to 1 second would be a waste, because if we were going to graph it that way, oh, I don't have a pencil. Does somebody have a pencil I can borrow? If we were going to graph it with the scale being all the way over to 1 second, it would kind of go like this. What's wrong with the scale if we made that end of the scale 1 second? It'd be way too big, right? So instead it says, sketch a graph for the time period in which it discharges to deliver an electrical shock to the patient. Well, in other words, how long does it take until half of it is left? Well, if you take E to the negative 33.3, you get 3.045 times 10 to the negative 15th. You get way too small an answer. That's this way over here. It's way too small an answer. Let's try 0.1 second. So if we took 1200 times e to the 330 instead of 3,300. Oops. 1200 times second function e to the, I forgot the negative, 330. It would still be way too close to, way too close. So even having 0.1 second would be too much. All right? Go to Desmos. Let's find a scale that works for this problem. So let's write the equation. V of t equals 1200 e to the negative 0.33 t. And when we do, if we go to 0.1 second as our horizontal axis, we get a graph that looks exponential. Goes down through 1200. And by the time we get to 0.1 second, it's down to pretty close to the axis. Why did my screen go off? We can't see it. Did I never turn on the screen? What I did before. How long did it take until it had reached its half-life? Well, what would its half-life be? 1200, I'm sorry, what would its half value be? 1200 down to 600, right? How long did it take until it got to 600? 0.02. So on your graph, if this is 1200, 600 would be here, and this number would be 0.02, which means 300 would be 0.04. which means 150 would be 0.06, right? Each of those is a half-life. If the first half-life was 0.02, 0.04, and so on, how could we figure that out? So we get these different values in there. Exponential functions should exhibit constant percent change. In this case, the constant percent change is 3,330% per second. Next equation. So we have the equation that says voltage as a function of time is 1200 e to the negative 33.3 t. Now they're going to tell us that the energy, I'm going to change colors. Energy as a function of voltage is, middle of the page, 0.0015 voltage squared. Oops, I should use purple here instead. So in other words, we're going to take this equation into wherever we see V in this equation. So we've got energy as a function of voltage is let's do it this way. Energy as a function of voltage is 0.0015 something squared. What is that something? It's this stuff here. 1200 e to the negative 33.3 t. Let's simplify this formula. First of all, how do we take care of that part there? That has to distribute into both parts of the parentheses. This part here becomes e to the negative 66.6 t. Do you understand how that part worked? What did the squared do to the exponent? Multiply it by 2. So we're good there. What is the squared going to do to the 1200? What'd you get, Sam?
1200 squared. Looks like it's 1.4 million-ish, 1.44 million.
So 12 squared is 144. 2 zeros squared is 4 zeros, right? Times 0.0015. So on our calculator, we would take .0015 times 1440000 is this part here multiplied out to be 2,160 e to the negative 66.6 t. So if voltage is going to decrease with time, energy is going to also decrease with time, but the amount of energy is going to decrease the square times as fast, right? Okay? Now, why does that happen? Well, think about it this way. The water is coming over the falls. There are two things that are happening with the falls. One of them is how far it's falling, but the other one is how much weight there is on that water, okay? And so the impact that it has on you is, they say, the square of the voltage. Not just the voltage, but the square of the voltage. So the question is E as a function of V also an exponential function of time? Is the exponent time? Yeah, it's 2,160 e to the negative 66.6 t. Page 337. Seven kilograms at time 0. .5 kilograms. Why, if I'm measuring radioactivity, would I pay attention to when it's to 3.5 kilograms? Because that's half, and usually we talk about half life. Well, let's say, what's going to be true about the time if we get down to 3.5 kilograms? It's going to be like, I don't know, they don't even give us a number, do they? Oh, they do. Yeah, they do give us a time. But it's going to be at a certain time that's going to be bigger than that. If we graphed that function, it would look like this. Correct? Go through 7, it'd go through 3.5. It would go through each one of those things. How do we know from the graph that it's a function? Why did I draw those yellow lines? Yeah, the vertical line test. Is it a function? Yeah, so it says, is mass a function of time? Mass is a function of time. If we were to graph this the opposite way, so that this is the mass axis and this is the time axis, do you agree it would go through this point over here, 7, right? And it would go like this, right? You would never have less mass than 0, but at some point in time, the mass would have been 3.5, and then half of 3.5, and eventually it would get really close to that axis, right? Is that a function? Yeah. So is mass a function of time? Is time a function of mass? Yes. Inverse functions. That's what we're talking about. One characteristic is they have to pass the vertical. And the other way we could have done it originally was we could have just said, does it pass the horizontal line test? So the vertical and horizontal line test. They are a 1-to-1. What does it mean to be a 1-to-1? Every input has one output. Every output has one input. There are no double Rooskies. Those are the two characteristics of an inverse function. So up until now, we've been dealing with a function written this way. F of t is 7 times 0.99 to the t. Question number 1. What is the beginning value? 7. Question number 2. What is the ratio between the next value and the previous value? 0.99. How far apart are they? Whatever that value of t is. In this case, t is 1. Remember, in the previous ones, we had different values of t, but they're telling us t is always 1. 1 hour, 1 week, well, in this case, it's 1 minute. Okay? So we're going to start there when we come back from our break.
Yeah, exactly. And that's why, like, and wants to get smaller. No, so I'm gonna ask Kevin if I get all these math science done, am I gonna pass it? I guess it could be worse, you know? Like, I need to complete this 18
How fast still percentage?
in the class,
Yeah.
57. Yeah.
So, I mean, even if you do at least decently more than that stuff, you should be able to know. Be at least 65. If you get me. So, I mean, I'm sure he'll be close.
Yeah, all I need is a 2.82 transfers, but I have 2.7 right now.
I'm scared for this When you read it, okay, well, I gotta see it close right now. It's like where? I don't know, I just don't think it. I do. See, I don't know. But if you do like that on the test, even you should not drop that far to the point where it's gonna like my whole.
I don't think it can. Even if I fail my test right now, I have a higher B plus. I'd be at a B minus at the very most. So you should. And how is this test? I don't know. I feel like we do this. Look, we literally do it 2 times, and I get like some of us do this and this, like all this. You just literally like move it out sort of much. So like the corners, funky, and that's why I don't either. I thought it was I mean, there's like
There's a
problems
few
where it's like,
correlating.
okay, yeah, this goes.
Yeah.
But I have
like
like
words for you, so.
I'm so I don't
And
know.
like, normally I feel like the only reason why I feel like this is right now is
It's not like-
because if I look at my test
For the
grades,
most
each class,
part,
one's an A, which was like Burke and 96, the other one was like a C, and I think the other one I just was like a C. Well, I don't think it is silence, so that's probably why he failed this class.
no, I go to the homework, and it's like the same. Previous assignments I get because I'm
She's
really
class
good
at
at
9,
seeing them work
so
out, and I'm like, doing it
if she
today.
makes up that
And
makes
it's
6:30.
working, it's like, huh? So then I feel like help it, and then I just have to
Me
look at it and
too.
be like, okay, this is what they did.
No, to be honest, that's literally,
25
I always need help with it, and when it has like 35 parts, I go through it because I still don't understand it,
Yeah,
which is like really
And there's
frustrating.
me, I just wake up like have like 10 minutes.
I just do it
When she
for my
gets
myself just to be able to
Just
Oh, you guys
I don't sometimes and the pissier I get, the worse my percentage
It's easier
is.
to
By the
just
time I'm
say-
done with all these like 27 assignments,
Everything's like right there.
it's so frustrating. And like the tests
This
are
one,
much
my
more.
mom's
And I do, it's like I can't even focus on
Yes.
it.
I mean,
This
this
is
is
like
like
high school patients.
But she had to
Before. Yeah, I'm literally, I feel like I'm gonna ask them.
That'd be fun.
I don't know, you guys just
Yeah.
I would literally show up. Yeah, like, even if we just like half the class.
Just like
And so, yeah, we walked over and
like say you just she wakes up early or whatever, and then I'm like save
and like, the thing is,
Yeah, I can.
essentially, yeah, actually, that's the
She
one
worries
my
a lot.
time on trying to figure it out, but literally just worries me so down.
at the same time twice.
Is she older than you?
Yeah.
It takes me.
My brother's like
It's just
brother
like-
and
Yeah.
Alex
I
is
spent
are
$5
the
at a
same.
time, and I split in half.
Yeah.
And I still don't spend that much time. Then you add, all of us were working at, not working at
I wanted to my time.
Yeah, I'm nine too now. I mean, I'm just sometimes it's so easy to watch it, so.
He just does it all and like
It's just.
Like this week, my boss is
Right,
working
that's the
26
same.
hours. And I said, oh, well, I guess that's a little bit less than 40 hours a week. For like 26 hours, I said, dude, I'm probably not going to come in if you haven't worked in it. She's like, well then, don't expect to have a job. She's like,
I wish I would have been watching the Miami and Patriots game yesterday at the end. That must have been quite a play. Poor Patriots.
Who won last night between the Bears?
I can't imagine that the Bears didn't win because they were up by 14 when I went to bed with like 3 minutes left. Or no, 12. They were up by 12. And it looked to me like Los Angeles couldn't figure out how to play in cold weather. Their quarterback couldn't hold on to the ball. I don't know. It just seemed like... I can tell you this. I lived in the South. And I lived by Tampa. And they always said, boy, I sure hope someday our Buccaneers will be able to play in cold weather. Because I think the entire time I was there, they never won a game in which the temperature was colder than like 58 degrees. Home or away. And they just couldn't play in cold weather. And I think it's still true that if you check Los Angeles teams, in fact, most teams don't win away from home in the NFL. You can check the statistics on that. Extra credit. Here we go. Where are we? Did anybody look up AEDs or not to see what the success rate is on them?
The Bears did win last night.
They
I'll
did.
look
Huh?
it up right now, Kevin.
I know it wasn't good. Oh, are no students in this class. I must have hit the wrong one. Courses. There we go. Let's try this. Yep, there are students in this class.
Well, I found out the percent for every minute that passes without one, but
How much is it?
30% to 50% of victims will survive if AEDs were used within 5 minutes.
Okay, well, that's not bad. 30%. I mean, it's not. The thing that I think throws people off is they see on TV, they shock them, and then 15 minutes later they're like back, running around, chasing the crooks or something like that.
Same with like CPR though. You think that would save someone's life, but majority of the time the person dies anyways.
They say it only works 7% of the time.
Yeah.
Which thing only works 7%?
CPR.
Oh, you didn't just look that up. That's
I knew that from something,
okay.
but I would say 7%.
I was CPR certified for like 3 years.
Okay, Nick's here. Michael is gone. Marlene is here. Gavin's here. Janae's gone. Felicia's here. Nicole's gone. Eric's gone. Phil's here. Grant's gone. Connor's here. Eric's here. Laura's here. Madeline's here. Jessica's here. Lauren is here. And Sam is here. Okay. So let's go back to where we left off. So we left off with this formula right here. Well, what does that formula help us do? It says, first of all, determine the mass after 15 minutes has elapsed. So what would you do? Well, you would take F of 15. Or in other words, you would take 7 times 0.99 to the 15. So let's do it on our calculator and see what we get. 7 times 0.99 to the 15. And sure enough, it's down to 6.02. Question number 1. We should go through what we know from this formula. This is the initial. This is 1% decrease. How do we know it's a 1% decrease? Because you always start at 100%. How do you know it's a decrease? Because 99 is less than 100. Okay? 1% decrease. But the 0.99 is also the ratio of the new to the old if the value is 1. So if they're 1 apart. If we went to 1 second, we would be able to find out how much there would be at 1 second. The next question that it asks is, at what time will the mass be 5 kilograms? Okay, so now we want F of t to be 5 kilograms. So in other words, 5 is 7 times 0.99 to the t. Do you see a problem here? We know the answer and we're looking for the question. Very good. Yeah, we're looking for the time. How can we do this if we're looking for the input? This is good review for the test. We can guess. Try different values for t, right? compared to 15, what's it going to be? Well, 15 was 6.02, right? We want the answer to be 5. So is it going to be more than 15 minutes or less than 15 minutes? Those are the two choices. Less and more are indeed the two choices. Would you like to get us down to only? Oh, actually, there's a third choice, the same. Would you like to?
I'd like to change mine.
2 more time. So if we're going to guess numbers, we should guess a number bigger than 20. If that number is too big, then we would guess a number smaller than 20. If it's still too small, we would guess a number bigger. You get it? We could just keep on guessing. We could also do it by graphing. Let's go to Desmos and let's graph it. What are you talking about now?
She said that
I just said
that
go with
was right away.
Oh, I would have just gone to Desmos right away. And in fact, here is 5. I graphed it, and it comes out to be 33.479 minutes. I forgot what I don't even remember. Yeah, is it minutes? 33.479 minutes. Right?
Yes, it is.
Okay. $33 minutes. I am not going to write 33.479. I'm going to change it into minutes and seconds. This is a test question. How do you change 0.479 into minutes? Now, yeah, you take the 0.479, right? What do you do to it?
Hours or
We're going to seconds.
times 60.
Times 60. So we're going to take the 33.479. We're going to take the 0.479 times 60. 0.479 times 60 is 33 minutes and 29 seconds. Okay? So we can graph. And now, since the title of this lesson is Inverse Exponentials, we're going to inverse. Here's how we inverse. We start with t. What's the first thing we do? We exponent t to what base? .99, right? So 0.99 to the t. Then what do we do? Times by 7. Very good. And we get 7 times 0.99 to the t. That is our mass. How do we go from mass back to time? What's the first thing we're going to do? Mass divided by 7. Oops, I'm sorry, we're going to divide by 7. Sorry. Divide by 7 and we get mass over 7. And now we're going to unexponentiate. Recall that I told you our our inverse operations. These two, what are the two inverses? A and S. Oh, come on, people. These two? And these two? Logarithm and exponentiation. The problem is, right now, we don't know what this is, and we're not going to learn it in this lesson. Because all we're doing in this lesson is finding that an inverse function has, exponent function has an inverse. That's all we're doing. Part 3. Let's take another one. G of x is b to the x, and this time b is greater than 1. 1 point something something. Because of that, what kind of a function is? Or a growth function. Remember, we were talking about the other one was decay because it was less than 1. This one is greater than 1. So when we graph it, we're going to start here at 1 in this case because there is no number in front of the b, so we'll just say it's 1. And are we going to go down? No, we're going to go up from there, right? It says, what is the domain and what is the range? Well, what are the values that we can have for x's? All of them, good. So from negative infinity to positive infinity. Because of that, we can't use brackets. We have to use parentheses. Okay? What happens to the range, the y values? Would you agree we start at 0? And we can go all the way up to infinity? Would you agree you can't have less than 0? Okay? Can you have less than 0 of a radioactive isotope? I have -5 uranium in me right now because I'm so old. No, I can't have less than 0, right? What is the domain and range of its inverse? Do you recall how do we graph an inverse function?
Can we just flip the x and y or no?
Yes, we can. Exactly. That's what we do.
Nice.
We flip the x and y, and so instead of going through over 0 up 1, we'll go through over 1 up 0. Instead of getting closer to this line, we're going to get closer to this line. What do we do after that? Well, we just keep on growing forever and ever and ever. So now our domain and our range, we should be able to figure out. Domain, where do we start? Good, 0, right? We can't go any farther to the left than 0. And how far to the right do we go? Buzz Lightyear? To infinity and beyond, right? The range. How far down do we go? And how far up do we go? The domain of a function is the range of its inverse. The range of a function is the domain of its inverse. Asymptotes. We'll agree that this one has a horizontal asymptote at 0. This one has a vertical asymptote at 0, right? Here's our vertical asymptote. Here's our horizontal asymptote. So we sketch the graph of the inverse function. Page 339. So we figured out a way to find the half-life when it was 3.5. And the way we did it was to use Desmos, correct? And we found T, I don't remember what it was, actually. When was it 3.5? Oh, we never did that, did we? 3.5. It's over here someplace. It was 3.5 at t equals, let's say 69, essentially. So is at about an hour and 9 minutes, it was half-life. In this lesson, it says, you will learn that log functions are inverses of the exponential function. Each logarithm function is associated with a specific base. Your calculator can be used to determine the outputs of log functions. Compute the output of a log function. Okay, so the first rule is a logarithm is an exponent. So let's start with the simplest one that we had, which was, I forgot. I want one with the, well, let's just take this one, and instead of it being 7 kilograms, let's say we would have started with 1 kilogram. We would have said the mass is 0.99 to the t. We're going to write that. This is in exponent form. We're going to write it in log form. So the first thing it says is a logarithm is an exponent. So t is going to be our answer. The log base, 0.99 of m equals t. So in this case, what's our base? It's the thing that the logarithm is based on, 0.99. What number is it? It's m. So log 0.99, base 0.99 of m equals t. So let's do a more general form. If you have a number m, and you're going to say that is equal to some base to some exponent, and I like using t as the exponent because most exponential functions are based on time. You know, like for instance, the amount of money you have in the bank is based on the amount of time that it's there. I have to think if I can think of an exponential function that is based on something other than time. Nope, can't think of one right off the bat. Look it up, extra credit. Okay. Log base b of m equals t. The logarithm is always the exponent. So back here, when we were doing this one and we were going through inverses, we got to this pot right here where we had m over 7. We're going to find the log of that. Well, what's the base of the log? The base is the same as the number that we had before. So this answer is going to be the log base 0.99 and this is our exponent m over 7. Log base, not our exponent, our number. So log base 0.99 of m over 7 is t. Next page. Where were we? Oh, here we go. We have to do these. So they get us into a different thing so that we can do some practices. Let's say we know it says that 64 is 4 to the third. That's what it says, right? Or in other words, the log base 4, notice the 4 is the base, of 64 is 3. How do you know to put the 3 on the other side? Because a logarithm is the exponent. Okay, so the log base base 4 of 64 is 3. Oh, where'd it go? Missing. Oh, there it is. Log base 4 of 64 is 3 because 4 to the third is 64. Next one. Log base 9 of 81 is something because 9 to something is 81. What's this something here? 2. 2. Next one is a little bit tougher. Log base 9 of 3. We don't know what that is, but we do know it's because 9 to some power is 3. Would you agree the 3 is the square root of 9? How do you do square root? 9 to the 1/2. Let's try it just to make sure. 9 to the 1/2 is 3. So the log base 9 of 3 is 1/2. Here's one clue about that. If the base is bigger than the number, then the logarithm is less than 1. If the number is bigger than the base, the exponent is greater than 1. Okay, let's try this one. Log base 9 of 1 is. Well, it's because I'm going to take 9 to a certain power and get 1. What power do I raise 9 to get 1? 0 it. Let's try it. Oops, clear. 9 to the 0th is 1. Log base 9 of 72 is 9 to some power is 72. Well, would you agree that power is going to be close to 2? Give me a number that's close to 2 that we could raise 9 to. 9 to the, what do you want to give?
1.8.
1.8. 9 to the 1.8, I got 52. So 1.8 is a little bit too small. So 9 to the 1.95, he says, is 72.57. So would you agree that's a teensy bit too big? Okay? So instead of 1.95, was 1.95 too small?
1.95.
I mean, sorry, 1.94, was that too small?
I didn't try that one.
You didn't try that one? 9 to the 1.94 is too small. So it's somewhere between 1.94 and 1.95. Everybody agree? Okay. Our calculator can find what that is. Here's how you do it on your calculator. Second function. Oh, I'm sorry, it's not second function, it's just math. Hit the math button and go down to where you see log base in math. On yours, I think your calculator will do it. Nope, your calculator doesn't. We will do it over here when we get to here, okay? And your calculator we will do when we get over there. What kind do you have, Felicia? Do you have a graphing or what is that?
It's a Casio.
Let me see it. I'll see if it can do it. Yep. It's this button right here. Is that the one that you press?
Yeah.
Okay, good. You're good. What are you using? You got it. You know how to do it on your calculator?
Yeah.
You got it. You got it. You.
Use it your calculator, so yeah. Got it.
Let's see your log. Oh, there it is. Okay, yours we have to use a change base. Yours we have to use a change base. We'll get there. Okay, so when we press that, it says, oops, clear. So I go to that, and you can see you just fill in the values. So I'll put in a 9 here and a 72, and it should come out to be close to 1.94 because that's what we kind of guessed. It was bigger than 1.94 and a smaller than 1.95, right? Okay. If you do not have that button on your calculator, let's look at the next page. It tells you how to do it. The change of base formula says, so I'm going to use the log key on my calculator instead. I'm going to take the log of 72, close parentheses, divided by the log of 9. Okay, so Connor, you see how to do it? Nick, you see how to do it? Felicia, you see how to do it? Marlena, you got it? Oh no, Felicia, yours worked because you had that other key. Who was the other person? Okay. So, Phil, did you find it on your calculator?
Yeah.
Okay. Okay, page 340. Fill in this table for each of those values, and they want you to use the two keys, the LOG key, which is the log base 10, and they want you to use the LN key, which is the log base E. For each of those values that they give you, 1, 2, E, 8, 10, and 18. Go. Are those the numbers that you got? When you did it? Because now it says to take the log value divided by the ln value. So, well, 0 divided by 0, that's undefined. But do each of the other ones. What do you notice? That ratio is always 0.43. Think about it this way. If we were going to graph them, they're both going to go through the point over 0 or over 1 up 0. Log base 10 is going to go through the point over 10 up 1. Okay, so it's going to come like this, right? The ln function, natural log they call it, is going to still go through the point over 1 up 0, but it's going to reach the number 1 back here at E. Up 1 when you go over E. Oops. Or about 2.8. So it's going to go like this. What's going to be true at every point? At every point along the way, if you take the bottom number divided by the top number, it's always 0.43. Now I don't have it actually drawn to scale, right? Because really what it should be doing, if I were going to really draw it the way it should be going like that, because it's always, the smaller one is always point. Why does that keep going to a blank screen? Is always 0.43. The purple line is always 0.43 of the red line. Page 343. Biologists determine that a particular species of rat first arrived on a Polynesian island as a result of colonization. Biologists assume that the rats stowed away on the vessel traveling to the island and were able to thrive in their new environment. Assume it experienced exponential growth. How could we use estimates of the growth rate and current population to estimate the time it took for colonization? Okay, so we know at this point right here, there are a certain number of rats. We know that it increased in the last year by this amount. If it were a linear function, can I borrow your pencil again? If it were a linear function, what would you be able to do with those 2 points? Right? Everybody agree? Now, couple questions for you. First question is, how do you know the growth of rats can't be linear?
Because rats.
Well, but if you look at the graph helps you understand something. If you go back far enough, what's going to be true? You're going to have negative rats. You can't have negative rats, correct? You had to always have started with a positive number. You can't have a negative number. Okay? So, we now have the growth rate, which means we can figure out the previous value. So now we're going to make a curve between those 2 points. We know how to go back to the beginning, right? A, that's the beginning value, is our growth rate to the t, right? Or in this case, we don't know how far apart those two t values are, so we'll just say t to the some power, or t over something. Because this is growth, what do you know is true about the r? It's greater than 1. Not it's positive, it's greater than 1. Okay, now it says, assume the rat population p as a function of time is given by 1.5 t. Well, now we can write this, can't we? P as a function of time, population as a function of time, is a times 1.5 to the t. Well, they say a is 1, so they must have started with 1. The thing that, I'm okay with starting with 1, but I can describe that rat very clearly if they started with 1 rat. Gender.
No.
Those are the two choices.
Female.
Female. Can you describe her more carefully? If there was only 1 rat on the entire island. What? She was pregnant. Okay. So if this is the population description, they're going to assume you started with 1 rat. Now, my hunch is when those rats got onto the island, I have a hunch. Either 2 ships showed up and, a rat jumped ship from each of them, or there were a bunch of rats on the ship and they jumped onto the island. Anybody ever have mice in their house?
Yeah.
What can you assume about mice? If you have 1,
There's more.
you have 2. Okay? Right? When you start killing them, never stop with killing 1 mouse. Because your house has more than mouse. It has mice. Got it? Okay. So we've got our growth rate as 1.5 t. Let's write this. Well, they say write it not as a function, but let's write this as a logarithm. Log base. Oh, I have this in the wrong spot. Log base 1.5 of the population is t. Remember, the logarithm is the exponent. Well, if this is our population function, you will agree that our logarithmic function is going to go through the point over 1, up 0, and it's going to take those 2 populations and go down this way, right? So they ask the question, does this have any asymptotes? Yeah, it does. It's got a vertical asymptote at 0, meaning the population can never be
0
or negative. So what's true about this logarithmic function is number 5. Is it increasing or decreasing? Now, Madeline, before you say your answer, think carefully because we already know there are 2 choices. So which one is it? What do you think, Lauren? Looks like the whole time it is.
I'm so lost and confused right now.
Okay. Somebody help her out? I don't know where you're lost and confused, but if you look at this function, what's it doing?
It's increasing.
Yeah, you're not as lost as you think you are.
Oh, that's it.
That's all,
Oh.
right?
That would be more too.
Then never mind. I was just kidding.
Okay. So, as you keep going forward along the graph, what keeps happening to the x?
Increases.
It keeps on increasing. So over the course of, as time gets bigger, the population will get bigger. As the population gets bigger, the time must also be getting bigger, right? Sketch the graph. Here are 2 points that we know for sure are on this graph. Over 1, up 0, over 1.5, up 1. Every logarithmic function has 2 points on it. 1 and 0, and the base and 1. You will always be able to graph those 2 points. So if they said log base 3 of p is t, how would our graph change? It would go through over 0, or over 1, up 0, but what would be the next point it would go through? Over 3, up 1. So it would go like that. We'll start there tomorrow. Do you have to buy batteries, or do you have a charger for it?
I have a charger, but I don't know where it is, so I'll probably have to go buy batteries.
Well, here. Plug it into your USB, or if you have a USB charger, you could plug it into your USB charger.
Okay, thank you. I'll
Yep.
get back to you tomorrow then. Is that okay?
Yeah. Yeah, I don't need it. I get a million of them.
You just have 3 pages that look smashed.
Okay, can I ask a quick question? So,
I have at least one quick answer. 42?
no.
Increasing.
It's not that. It's not that one.
Decreasing. Okay.
So I have like a lot of assignments to finish still, but if I do those, will my grades still go well?
Well, let's look.
Which is passing.
Do you have a second?
I already know how many assignments I have to finish because I was like counting all of them.
Okay.
I did 18 last night, so
You did 18 of them last night?
but I have like 82 left. So.
82. Okay. Oh, I have to go this way to do it. Let's see. Log in. Check my mail.
Keep straight face.
I
Yes.
couldn't get anything done this weekend because I was wondering.
Go back. Open my OneDrive. Goat. What? Come on.
Because like the thing is that my other class, my grades are so good in other classes that I'm still gonna be able to transfer, but I have to transfer.
Are you transferring next semester?
No, next